right? But one thing to be aware of here, and maybe I'll just run this again. Okay, good. So what you could see here is that it's matching the table that we expected it to, right? 0, 0, 0, 0, 1, 0, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 5, 2, 6, 3, 7, etc., right? And you see here it stopped at what looks at 417, right? It didn't actually stop at 417. 17, if you count this out, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right? 17 was the position of this O, right? So at this point, there are 4 vowels before this second O. So now what's going to happen is you're going to say, okay, ACC is 4, current index is 17, right? And you're going to say, is S of 17, that's the O, the second O, is that a vowel? And it is. So what are you going to do? You're going to return accumulator plus 1. So now the accumulator is 5, right? But the current index has just moved up to 18. So when it checks 518, it's going to say, is 5 equal to the input n of 5? And it is, so it's going to stop, right? So it's stopping with current index of 18, right? But remember, the vowel that we wanted was at position 17, right? So what you're not seeing here is you're not seeing that final row where it stopped, which would be 518. So what you actually do here is you have to say, okay, remember that the this thing over here, this first index with n vowels before, right, is going to store the index, right, where the accumulator became 5. So it means that at this position, right, at position 18, there are 5 vowels before position 18, right? And it was the first such one where there were 5 vowels before position 18. So that means the 5th vowel had to be at position 17, right? So you can think about why that's true, but basically it was like 4, you could see it was like 4, 4, 4, 4, and then as soon as it became 5, right, in order for it to become 5, right, we were checking the character at position 17, and that's what bumped it up to 5, right? So that was our 5th vowel. Okay, so what we're going to be getting is a row. This thing would return a row. The 5 was the accumulator, and the 18 was the position that we were up to, right? We obviously want the position because we know the accumulator is 5, right? That's where it stopped. We stopped when the accumulator was equal to n, and we knew our n was 5. So we want the item, which we said was 18. Now that gives us, again, one more than the position that we want. The position of the vowel is 1 before that, that 5th vowel. So we took this answer here, subtracted 1, right? And so now we got the position of the vowel that we want, and then we did S of that to get the actual character there, to get the vowel that's there. Okay, so this is how we solved the problem. I just want to mention this. Well, first of all, I could just sort of mention that is vowel. You could see how this works. It's just converting the letter that you give it to a lowercase one, and then just once it is, it checks whether it's lowercase a, lowercase e, I, O, or U. All right. Okay, but the main thing I wanted to say is that you did not have to have the table this way, right? So if you didn't want to do this -1 at the end, another way of solving this problem would be to actually make the item, instead of the accumulator representing the number of vowels before this position, you could make it equal to the number of vowels up to and including this position. So this is, our table would change a little here. We would say over here the T was, what was I going to say here? The T was not a vowel, right? So there's zero vowels before position 0, or 0 vowels up to and including position 0, 0 vowels up to and including position 1, and now we'd have 1 vowel up to and including position 2, right? So this 0 would become a 1, right? And we'd say then there are still 1 vowel up to and including position 3, still 1 vowel up to and including position 4, 2 vowels up to and including position 5, 3 vowels up to and including position 6, and then still 3 vowels up to and including position 7, right? So if our accumulator represents the number of vowels up to and including that position, right, then we would, when we actually get what we would have in that last one would be the 517 that we wanted, right? So we wouldn't have to subtract 1. But what else has to change? So again, we have to think about from this table, right? The accumulator is still the same in this example, although you have to be careful. I'll mention that in a moment. But over here, what we're doing, right, each time to figure out whether the accumulator goes up by 1 or not, is not checking S of current index, right? Because like, for instance, over here, if you check S of current index, you're checking S of 1. So if you're checking if S of 1 is a vowel, it's not, so you would still keep the accumulator at 0. Instead, because you're moving on to 2, and 2 should represent the number of vowels up to and including 2, when you're at 1, you don't want to check the character at position 1, you want to check the character at position 2, right? And when you're at 2, you want to check the character at position 3, right? Etc. So how that changes it is instead of checking S of current index, you would have to check S of current index plus 1. The other thing that would change is you would need to say that you don't want to stop at S dot length anymore, right? Because you could see that if you stop at S dot length, if you potentially, what was I going to say here? If you potentially had where the index right now, or current index, was S dot length minus 1, now you would be checking S of S dot length minus 1 plus 1, which is S of S dot length, and there is no S dot length, right? Or there is no character at S dot length. So you want to actually make this a minus 1. That would be the furthest that you go. So that's another change here. The final change, it won't make a difference here, but one thing that's very important is the fact that this initial letter might be a vowel. So if you start the accumulator at 0 and you have this relationship that the item, that the accumulator should represent the number of vowels up to and including the character that's at this item, then you have to make sure that item 0, or the character at position 0, is not a vowel, right? Because otherwise this would have to start at 1. So this dot starting with ACC of would change based on the situation. So this is sort of a, it's sort of a little syntactically ugly, or it just might be a little confusing, but sort of a way of doing like an if-else type thing. You know, if it's a vowel, started at 1, otherwise started at another, is this use of the ternary operator, which you won't use in general, but I'm just to, make this work just in general without adding without adding extra code here, or too much extra code. I'm just going to make this, I'm going to ask if the first character, or the character vowel, character at current index, not current index, S of character, sorry, position 0, if that's a vowel, right, then I want this to start at 1. Otherwise, I want it to start at 0. So this is sort of a, again, sort of not very intuitive notation, but what this will evaluate to will be dependent upon whether this is true or not. So if this is true, it's going to be this. If this is false, it's going to be this, right? So it's saying if it's a vowel, this whole thing is going to be 1. If otherwise, it's going to be 0. So you could just do this with an if and an else outside of this here. So you could put like this, for instance, up here with an if and an else. All right. Anyway, not that major of a point right now. So I'm just going to run this, and you're going to see this time that it only goes to 16, right? There are 4 vowels up to and including position 16, right? And then it would stop at 517. And so there are 5 vowels up to and including position 17. And so we would want the character at position 17. Okay, so that's basically it for this problem. Just to complete this, the last thing was asking you what I basically was telling you. Every time countif vowel is called, ACC will be the, so in the original setup, we said it was the number of vowels before the letter at position current index, right? And just to bring out why some of the other answers wouldn't work, number of characters always staying the same. That's not what the accumulator is. Number of vowels, again, always staying the same. The total number of vowels in the string, that's not what the accumulator is. Sometimes the accumulator is 0, which is also why it can't be like the number of characters. It's not going to be n is always going to be 5 in this example, or whatever you give the input, right? If you give an input of 7, it's always going to be 7. The accumulator is not always 7. And then it was just a matter of whether it's number of vowels before a letter at position current index plus 1, or number of vowels before a letter at position current index. So we said with our first setup, it was the number of vowels before a letter at position current index. In our second setup, we had the number of vowels up to and including the one at position current index. So that would be the number of vowels before a letter at position current index plus 1. But for the setup I gave you originally, it's the number of vowels before the letter at position current index. Okay, so hopefully that clears up this problem.